Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.0, Episode 6. Okay, let's continue from where we left last time. In this chapter, we will see the final preparations for the LFS build. In this chapter, we will perform a few additional tasks to prepare for building the temporary system. We will create a set of directories in LFS folder for the installation of the temporary tools. Add an unprivileged user to reduce risk and create an appropriate build environment for that user. We will also explain the unit of time we use to measure how long LFS package takes to build or SBUs and give some information about package test suites. Creating a limited directory layout in LFS system. The first task performed in the LFS partition is to create a limited directory hierarchy so that programs compiled in chapter 6 in the subsequent chapters, as well as libc and libstdc++ in chapter 5, may be installed in their final location. This is needed so that these temporary programs will be overwritten when rebuilding them in chapter 8. Create the required directory layout by running the following as root. So what we will do is we will create some of the directories which are mentioned here. So we will have to run it as sudo because it says we have to run as root. So make dir will create a directory and -p is for uh, creating the subsequent directories, and v is for verbose. So we'll know what happens, whether it is success, whether it succeeds or not. So that's the understanding here. Okay, I'll enter the password. Yes, so make dir create a directory. All of the directories are created. Okay, for I in bin ls bin sbin do okay ln user $i for each directory. So basically we're creating a link, a soft link to user of bin lib and sbin with the lfs user bin and sbin. I think it's better to how do I do it now? Let's see if I can do this. Okay, it works. So ln then I'll go for done. Ln failed to create symbolic link. Okay, it's permission denied. So what I have to do is I have to do a sudo. Okay, now it's created. Fine. Then case uname -m, basically it's the user. If it is x86 64, then we create this particular uh, directory, basically lib64 here, case CASE. We're closing the case basically. Yeah. Okay, I need to do basically with sudo. That's okay. Created the directory because our, if you see the uname of an M, our architecture is x86-64. So that is the reason it got created. Okay, so program in chapter 6 will be compiled with a cross compiler. More details will come in the further chapters. In order to separate this cross compiler from the other programs, it will be installed in a special directory. So it will be, so all these cross compilers will be installed in the tools directory. So that is important. Okay, so now we have created the necessary folders, and then let's create, let's go to adding the Lfs user. So for us to work with Lfs, we have to create an user and group called Lfs. So we are adding a group called Lfs. Okay, I need to go with sudo because I have to do it as the root, and user add s-bin bash g lfs m-k dev null lfs. So basically here we are adding the user called Lfs. Okay, okay, so I need to do it with sudo. Okay, so you see he has clearly explained what this does. The -s bin bash, this part, makes bash the default shell for the Lfs user. The -g Lfs, this option adds user Lfs to the group. So -g is for adding to the group Lfs. -m creates -m. This creates a home directory for Lfs. -k dev null. This parameter prevents possible copying of files from the skeleton directory. Default is etc skel by changing the input location to the special null device. So basically you're just throwing off. Lfs, this means the actual name of the created user. So here we have created an Lfs user and added to the group Lfs. To log in as Lfs as opposed to switching to user Lfs when logged in as root, which does not require the Lfs user to have a password. Give Lfs a password. So we need to give Lfs a password. This also needs to be done as root. Okay, I re-entered the password. Password successfully created. So grant Lfs full access to all the directories under Lfs by making Lfs the directory owner. So if you see, let's just see ls. If you just wanted to see, okay, sorry, ls-l, we'll just do a long list. Okay, so here the owner is root. So user and the owner both are root here. So we need to change that to the Lfs. So chown is basically change the ownership to V is for verbose. It will say what happens during this operation. Change the ownership to LFS. So that is what we're going to do now. I think this also needs to be done as a root. I suppose. Okay, let's see if it works. Failed to change because permission denied. We'll do with sudo. Okay, it's LFS. So now if we do an ls, you see the root. Okay, for some it is changed. It is retained as LFS. Ownership of LFS is changed. Okay, let's see. So user libvar etc bin bin tools. Libvar 3. Grant LFS full access to all directories under LFS. Why it is not done? Change ownership of retained as LFS. That's fine. Ownership of mount bin LFS. LFS lib. Okay, let's see. I think it should happen. Okay, so the case is something like this. Let's see if it works. Okay, failed because it's not sudo. I have to use sudo. For the other one, which the lib64 also it's changed. Okay, for some reason the user is not happened. USR sources bin the root. Okay, for etc it happened. Lib still the root. If a separate working directory was created as suggested, give user. Okay, for the sources also we have to give this ownership to LFS. Okay, now let's check it. Okay, so LFS, I would say bin ownership of maintenance retained as LFS, and I'll check for the lib. Okay, assume it's okay. Note, so in some host systems, the following command does not complete properly and suspends the login to LFS user to the background. If the prompt LFS does not appear immediately, enter the fg command will fix the issue. So we'll use the switch user. Next, login is user LFS. So what you're doing is switch user to LFS. It will ask the password. Yes, you see, now we are the LFS user. The hyphen instructs the SU to start a login shell as opposed to non-login shell. The difference between these two types shell can be found in the detail in bash 1 and info bash. That's fine. Okay, so let's just think what they are. So I will just create one more terminal. Terminology, add a favorite, add var. Okay, I'll not go deep into it. Then setting up the environment. Set up a good working environment by creating two new startup files for the bash shell while logged in as user LFS. Issue the following command to create a new .bash file. Okay, so let's just see ls or pwd and see where we are. We're at home of the LFS user. Okay, and now what we will do is we will create a bash profile file. Okay, and end of file. Okay, and let's see a okay bash profile file exist. When okay here if I understand execute environment I home is we're setting we're basically setting the environment variables here. Home is the home dollar home environment variable. If I echo this, we will get home as home LFS. This is the home directory. The term is the terminal. It's the terminal is xterm. What we're using ps1. Okay, let me just when logged in as user LFS. The initial shell is usually a login shell which reads the etc profile of the host, probably containing some settings and environment variables, and then the bash dot bash underscore profile. The exec env hyphen I, the dash dash bash command in the dash profile file replaces the running shell with a new one with a completely empty environment except for the home, term and ps1 variable. So except these variables, everything else will be empty. This ensures that no unwanted and potentially hazardous environment variables from the host system leak into the build environment. So if I just echo, so basically nothing exists. Oh, no, let's see. How do I check the environment variables? Okay, this ensures okay, no unwanted potentially hazardous environment variables from the host system leak into the build environment. The technique used here achieves the goal of ensuring clean environment. So the purpose is to have a clean environment for our build purpose. The new instance of the shell is non-login shell, which does not read and execute the contents of the etc profile or bash profile files, but rather reads and executes the dash bash hrc file instead. So for that, we need to create bash hrc file. Just copy and paste it and see. Later we'll see the meaning of this. Fine. So ls -a Yes, we have a bash HRC file, bash RC file. Meaning in this file is set h plus. Command turns off bash hash functions. Hashing is ordinarily a useful feature. Bash uses a hash table to remember the full path of executable files to avoid searching. Okay. So by switching off the hash function, the shell will always search the path when a program is to be run. As such, the shell will find the newly compiled tools in LFS tools bin as soon as they are available without remembering a previous version of the same program provided by the host distro. Okay, umask. Setting the user file creation mask. Okay, umask 200 ensures that the newly created files and directories are only writable by their owner, but are readable and executable by anyone, assuming the default modes are used by the open to system call. New files will end up with permission mode 644 and directories with mode 755. So LFS, this is a LFS variable should be set to a chosen mount point. The mount point is mount LFS. LC all is POSIX. LC AL variable controls the localization of certain programs, making their messages follow the conventions of specified country. Setting LCAL LCALL to the POSIX or C to or equivalent ensures that their everything will work as expected in the chosen in the chroot environment. LFS TGT uname -m LFS Linux GNU. The LFS TGT variable sets a non-default but compatible machine description for use when building our cross-compiler and linker when cross-compiling our temporary toolchain. More information is contained in toolchain technical notes. Path is user bin. Many modern Linux distributions have merged bin and user bin. In this is the case, the standard path variable needs just to be set to user bin for chapter 6 environment. When this is not the case, following line adds bin to the path. So here if -l bin, if it is not -l bin, then the path is set to bin and sbin both gets added. If bin is not a symbolic link, then it has to be added to the path variable. So that's how it works. Path is equal to LFS tools bin. It just concatenates the previous path by putting the LFS tools bin ahead of the standard path. The cross compiler installed at the beginning of chapter 5 is picked up by the shell immediately after its installation. This, combined with turning off hashing, limits the risk that the compiler from the host be used instead of cross compiler. Config site LFS user share config.site. In chapter 5 and 6, if this variable is not set, configure script may attempt to load configuration items specified to some distributions from the user share config site on the host system. Override it to prevent potential contamination from the host. Export dot. While the above command have set some variables in order to make them visible with any subshells, we export them. So some important note here. Several commercial distributions add non-documented inst- instantiations of etc bash rc through the initialization of bash. This file has the potential to modify the LFS user's environment in ways that can affect the building of critical LFS packages. To make sure the LFS user's environment is clean, check for the presence of etc bash hrc, and if present, move it out of the way as root user. Okay, so I need to move it as root. So sorry, sudo. Okay, after use of LFS user is defined within. Okay, after use of the LFS user is finished, at the beginning of chapter 7, you can restore etc desired. Note that the LFS bash package will be okay. We will build in this section is not configured to load or execute etc bash hrc. So this file is useless on a completed LFS system. So basically, I need to come out of this, or how do I? Okay, I need to have another terminal to do this activity. Cannot move. Why? Who is the owner? Let's say, oh, yes, what I did is we need to do an LSL. Okay, so I need to have a permission this file. H chmod. I need to have a user plus. I'll just give 7. Okay, we cannot move. Permission denied. Why it is so? Okay, I'll live with that. Let's see. I need to run as a root user. So let me run in the shell itself. Permission denied for some reason. That's okay. I'll close here. So finally, to have environment fully prepared for building the temporary tools, source, they just created user profile. So we need to add it to sources and then we will do it. Boom. I'll do a sudo. Oh, no need of sudo. Okay. So now the environment is prepared basically. About SBUs, here uh, many people would like to know beforehand approximately how long it takes to compile and install each package, because Linux from scratch can be built on many different systems. It is impossible to provide accurate time estimates. The biggest package, glibc, will take approximately 20 minutes on the fastest system, but could take up to 3 days on slower systems. Instead of providing actual times, the standard build unit SBU measure will be used instead. The SBU measure works as follows. The first package to be compiled from this book is binutils in chapter 5. The time it takes to compile this package is what will be referred to as the standard build unit or SBU. All other compile times will be expressed relative to this time. Okay, so for example, consider a package whose compilation time is 4.5 SPU. This means that if a system takes 10 minutes to compile and install the first pass of binutils, it will take approximately 45 minutes to build this example package. Fortunately, most build times are shorter than the one for binutils. In general, SBUs are not entirely accurate because they depend on many factors, including the host system's version of GCC. They are provided here to give an estimate of how long it might take to install a package, but the numbers can vary by as much as dozens of minutes in some cases. For many modern systems with a multiple processor, basically we can use export make flag hyphen J4, or just while building we can use make hyphen J4. Uh, it will just allocate to different processes. Basically, multi-threading will happen. About the test suites, most packages provide a test suite. Running the test suite for a newly built package is a good idea because it can provide a sanity check indicating that everything compiled correctly. A test suite that possesses its set of checks usually provides usually proves that the package is functioning as a developer intended. It does not, however, guarantee that package is totally bug free. Some test suites are more important than others. For example, the test suites for core toolchain packages, GCC, binutils, and glibc, are of the utmost importance due to their central role in properly functioning system. The test suites for GCC and glibc can take a very long time to complete, especially on slower hardware, but are strongly recommended. Note: running the test suites in chapter 5 and 6 is impossible since the programs are compiled with cross compiler, so are not supposed to be able to run on the built host. A common issue with the running the test suite for binutils and GCC is running out of pseudo terminals. This can result in higher number of failing tests. This may happen for several reasons, but the most likely cause that the host system does not have dev PTs, dev DEVPTS file system set up correctly. This issue is discussed in greater detail at this link. Sometimes package Systems has no more PTYs. Ask your system administrator to create one more. Okay. When we have issues, then we will see. Sometimes the package test suits will fail, but for reasons which the developers are aware of and have deemed non-critical. Consult the logs located at LFS build logs to verify whether or not these failures are expected. This site is valid for all tests throughout the book. Okay, this is location where the tests exist. Okay, let's keep this tab. Okay, so now we have basically set the environment for our build, and in the next episode, next session, we will start building the LFS core tool chain and temporary tools. Thanks for watching. Please do subscribe to this channel and leave a comment, any feedback if you would like to give. Thank you. Thanks for watching.